Alright guys, today we're going to look at trying to figure out what is a logarithm. So to start, I want you to do this as a warm-up. I want you to take a guess at what these things are saying. So there's nothing for you to do on this side. But using what these mean, I want you to try and fill in these blanks. Okay, so take a second, pause this, and then we'll come back together in a moment. Alright, so have you figured out the rule yet? If not, you should keep this video paused. Okay, hopefully now you see that this little number, 2 to the third power equals 8. 4 to the second power equals 16. And so on. 3 to the fourth power equals 81. Now I want you to try to fill in these blanks using that rule. Alright, so let's fill these in. So 6 to what power equals 36? 2. Yeah, 6 times 6 is 36. So 6 squared. Okay, now 5 to the third power. 5 to the third power equals what? 45. Okay, now we have to think about negative exponents. 2 to the negative 1. Remember, anything to a negative exponent just changes position. So 2 to the negative 1 becomes 1/2. Okay, so whenever we have a whole number raised to an exponent, we're going to end up with a 1 over something. What to the power of 2 equals 81? 9. So we have like a little 9 down here. Okay, now for this last one we use the same rule. Like, see how this 2 became a half? Well, how do we make 10 into 1,000? 10 to what power equals 1,000? 10 to the third equals 1,000. So 10 to the negative third will equal 1 over 1,000. Well, what you just discovered is a log. Okay, a log is an exponential. See, these are, instead of the word power, now I've just written the word log. Log base b of y equals x. If and only if this b to the x equals y. So that's exactly the same thing that we just saw. This little number raised to the power on the other side of the equal sign equals this. And we read this as log base b of y. So notice that it's a little b because it's like a little sub number. Okay, so the next thing that I'm going to show you is how we can change between these two versions using this loop. Okay, the loop. A lot of people teach this in a lot of different ways, but I've come to find that the loop is the easiest way to do this. Okay, so like let's take log. Oh, need my pen out. Okay, let's take log base 2 of 8 equals. What does this equal? Log base 2 of 8. Yeah, that's right, 3, because 2 cubed equals 8. And plus we did that in the warm-up. Okay, the loop, you start at the base. So which one is the base? The 2. Start at the base, go around the equal sign, and then finally to the other number. And now you just write it in the order of the numbers that it touched. Okay? So the first thing that we touched was that 2. So 2. The next thing, whenever we went around the equal sign, the next thing that loop got close to was the 3. So 2 to the third. And then set it equal to the last number that it touches, 8. Alright, now if you had an exponential and you were asked to rewrite it as a log, like let's say you had 4 to the x equals 1/16. Right? Even though we could solve for this, let's rewrite it as a log. I'm still going to start with the base. Now the base is different. Now it's the base of an exponential. Which of these is being raised to a power? The 4. So the 4 is the base. So you start with the base, go around the equal sign, and this time we'll end at the exponential. So let's try to rewrite that. That'd be log. What's going to be the base of the log? log base 4, okay, of, what was the next thing that it touched? 1 over 16 equals x. Alright, really good job. Let's practice that a few times. Alright, the first 3 examples I want you to try to rewrite as an exponential, and then the next 2 I want you to try to rewrite those as a log. Okay? So pause this, and we'll come back together in a minute. Come back together. Pause. And we're back. So, remember that every single loop, hey, also, the loops don't always go around to the right. Okay, you always just start with the base. These just happen to be written in that direction. So we start with the base of 2, go around, hit the last number. So the very first thing I touched was 2, or the first thing. I went around to 4, so 2 to the 4th equals 16. Is that true?
Yes.
Yes. Okay, on the next problem, start with the base, go around. So the first thing I touched was 4 to the 0 power equals 1. Anything to the 0 power equals 1. Perfect.
So you can ignore the whole log thing, right?
1/4 to the negative 1 equals 4. Is that true? Yeah, because this 1/4 being raised to the negative 1, that lets you know that that 4 is in the wrong spot. Switches. Alright, if I want to rewrite these as a log, well, I can go ahead and just write log. Let's do that. Alright, now, what's the base of the log? The base of the log is the base of the exponent. So the base first, so log base 12 of 12 equals 1. So let's log base 12 of 12 equals 1. And this right here, this is a very important property. Okay, we're going to talk more about that later. Log base 1/3 of 9 equals negative 2. Log base 1/3 of 9 equals negative 2. Okay, so that's how we rewrite as an exponential or rewrite as a log. Let's talk about evaluating. Actually, before we talk about evaluating, I really quickly want to talk about common log and natural log. A common log is a log with base 10, right? So if it's a log of base 10, since that happens so often, you don't have to write that log base 10. We can just say, okay, that's log. Alright, so as an example, log base 10 of 100 equals 2, right? Because 10 squared equals 100. That's the same thing. We can just write this as the log of 100 equals 2. So it's assumed if you don't have a base and it says log, it's assumed that that base is 10. Okay, and that's called a common log.
So if you ever just see a log,
I didn't get what you just
Okay,
said.
so that's also why your log button on the calculator has a second log on the calculator is 10 to the x, because you'd have 10 raised to some power. The natural log, that's if you have log base e. Okay, a log base e we just write as ln. So log base e occurs so often that we just call that the natural log, because it has a natural base, right? The natural base is e. And that's what we talked about whenever we did exponential functions. So, like you might have the log of base e of 2 equals 0.693, right? So what that means is e to the 0.693 equals 2. And this decimal actually goes on. You could just rewrite this as the natural log of 2 equals 0.693. So again, if you just see the word log with no base, the base is 10. If you see the ln without a base, the base is e.
We're going to have to do a lot of this.
So this is base 10, base e. Okay, now to evaluate logarithms, it's best to just imagine this like it says equals x, and you're just solving for x, right? But these don't just say equal x. But if it did, you would think 4 to what power equals 64, right? So whenever you're looking at this, let's see if I can get rid of that little x. Okay, whenever you're looking at this, you just got to think 4 to what power gives me 64? Well, 4 to the third power equals 64, right? So log base 4 of 64, and you should practice saying that, log base 4 of 64, that's the same thing as 3. Because 4 to the third power equals 64. So it's just like you're saying, oh, okay, that equals 3. And just like in the warm-up, 4 to the third power equals 64. Okay? They just don't have equal signs. I mean, you could set these equal to x and solve for x if you wanted to. Okay, let's jump to b. Log base 5 of 0.2. This might be easier for us if we change this to log base 5. 0.2 as a fraction is 1/5. Okay, so now 5 to what power? 5 to what power equals 1/5?
Negative 1.
-1. Right? So it's just like we're saying equals -1. And if it helps you, like set it equal to x and do a loop, right? That'd be 5 to the x equals 1/5. If that helps you. Okay, but you don't have to. Alright, in the next example, okay, so 1/5 to what power equals 125?
Negative.
So the best way to think about these is just to think, okay, if this wasn't 1/5, if it was 5, 5 to the third power equals 125, right?
But since it's a fraction.
But since this is a fraction, then I have to raise it to a negative exponent. So 1/5 to the negative third will equal 125. So my answer here is just -3. Finally, to evaluate this last problem, we're going to have to remember our things about radicals. Like, we know that 6 squared is 36. But how do I get from 36 back to 6, right? Like, 36 to what power equals 6?
Yes, 1/2.
Yeah, it's 1/2. So taking the square root is the same thing as raising it to the 1/2. So 36 raised to the 1/2 will give you 6. And you can check that with your calculator just to make sure. But yeah, taking the square root is the same thing as raising something to the 1/2. Alright, so we'll dive more into logs tomorrow, but this is where we'll stop today. Your assignment is page 503, 3 through 6, and 8 through 19. It's a pretty short assignment. Alright, goodbye.